So question 10 is pretty straightforward, except they throw this twist at us and they ask us to write these in first term form. And that was a recent math note, so you might go back in your book and look at it a little bit. I'm going to discuss it here. If I'm just looking at these in terms of sequences, though, it appears that this first one is increasing, just looking at it, by a constant of 1,500. 1,500. And it's starting out at 500. So if I was to write this as an equation, it would be y equals begin at 5, no, not begin at 500x. Well, it is beginning at 500x, but each time I'm increasing by 1,500 times x, and then plus my initial value. So that's the equation that models that. And you can see if x is 0, 1, or 2, it's producing the correct values. On the next one, it's not arithmetic, right? I'm multiplying by the same value each time. And in fact, I believe the value I'm multiplying by is 3 times 5 is 150. Well, except it's 30. 30 times 5 is 150. And if I multiply by 5 again, and you know what, I want to just verify this one. So I've got 150 multiplied by 5. It's a 0, we've got a 25, 5. Oh no, it's a 25, 5, and it is 750. So it appears that, and I might want to check the last one with my calculator, but it appears that each time I'm multiplying by 5. So my multiplier is 5, and my first value is 30. So if this is as an equation, right, 0, that's the first, that's the second, that's the third, that's the fourth. So the equation is y equals starting out at 30 times 5 to the x power. So that's what these look like as equations. But they want me to write it in quote-unquote first term form. So let's discuss what that looks like a little bit. Let's consider this sequence right here. The sequence that's got the 3, 8, 15, I'm sorry, 3, 8, 13, 15. And for this sequence, it is arithmetic. Each time I'm increasing by adding another 5. And it starts out at 3. So the equation would be, y equals 5x plus 3. Now, where this first term form comes from is in an arithmetic sequence, we don't refer to the very first position as the 0 position. We would say it's the first member of the sequence, right? So in an arithmetic sequence, the first term is the number 3. The second one is 8. The third one is 13, and the fourth one is 15. This is the exact same sequence. It has the same values, 3, 8, 13, 15. But instead of saying we're starting at 0, we're starting at 1. So we can get the first term, the second term, the third term. In order to do this, it's just a small adjustment, right? If I write this in function notation, f of n equals 5, not times n, but n minus 1 plus 3. So by making this small adjustment right here, and multiplying this by n minus 1 instead of just the x, right, I'm able to shift everything back and write it in the first term form. I can verify the same thing's happening now. So when n is 1, when I plug 1 in there, I get 5 times 1 minus 1, which is 5 times 0. Same thing I would have gotten over here. 1 minus 1 is producing the 0, and then plus 3, and then that equals 3. When n is 2, you can see n is 2, that becomes the number 1 when n is 2. Over here, that was the 1, right? So again, it's producing the same outputs. So bottom line of the story is, it appears that if I want to write things in first term form, all that I need to do is make this one adjustment. Instead of having an x, wherever there's an x, we're just going to write n minus 1 instead. So if I come back over here to this problem, and I want to transform these so that they're in first form, or first term, all that I need to do is just, instead of having the x here, and instead of having the x here, we're going to replace that with n minus 1. in both cases, n minus 1. And in fact, I'm going to choose to write them in function notation. So I'll say that f of n, right, n's the input value, n's the number that goes into this function, equals 1500 times n minus 1 plus 500. And for the geometric one here, it's going to be f of n equals 30 times 5 raised to the power of n minus 1. So that's what we mean by first term form, and I've just kind of shown you how to go from an equation into that form.